Hey, hey. Okay, so we are live. I'm just gonna wait for some people to come on so I can actually have a chat. Hello, Addictive Photographer. Hi. Hello. Just waiting for a few more people to come on, and then I'll give a bit of an intro about me and about what I do, and we'll get some questions going. Hello. Hi, Genetics Research 101. Hi. Okay. We're just waiting for a few more people to join and then I'll get going. I've got my cup of tea in my NASA mug. Has anyone else got any drinks, beverages or snacks going, joining me in my tea? Thanks. It's actually my boyfriend's, but I've stolen it because it's super sciencey and fun. It's a NASA mug. And also I really like tea, and I need like a lot of tea to keep me awake. So it's a really good mug because it's super big. But yeah. Oh, and there's my lobster. You might have seen from the intro video. That's Lobby. I got him when I went to Boston for a conference a couple of years ago. So obviously, because I was in Boston, I needed to get a toy lobster because, you know, what else do you get from Boston? Hi everyone who's joining now. Yeah, hiya. Where's everyone from today? Are you UK based, in America? Tell me whereabouts in the world you are. Hello. I'm just gonna wait for 5 minutes for people to join and then I'll get going properly because I know that it's difficult to be on time on a Sunday, so we'll wait for a little bit. Oh wow, Blue Sunbird from India. That's cool. What time is it in India right now? USA, London. Oh, so cool. Isn't Instagram awesome? Hello. Oh. Yeah, what time is it everywhere? Because I know US it's 10. I obviously looked this up from the video. So US it's 10. Here it's about 3 o'clock. Colombia around. Wow, we're really going global, aren't we? 7:30 in India. From India, based in York. Oh, York's lovely. York's really nice. And what beverages do we have with us? Have anyone else got tea? We've already talked about my mug, but what drinks or snacks have you got, if you've got any? Hi everyone joining. Hello. We're just waiting for a few more people to turn up. I've just said, I know it's difficult to be on time on a Sunday, so I'll just wait a few more minutes and then I'll get going. Please start sending any questions that you have in. I've only got one question currently, so please, like anything. I'm up for answering anything at the moment. Anything about my research. Obviously, I'll go on to talk about my research a bit more in a second. But yeah, let me know and I'll jot it down and answer it in a bit. And where's everyone from who's just joining now? Let me know. Don't be scared. This is a discussion, not a one-way thing. I want it to be a two-way thing. Hello, people joining. Hi, everybody. Hello. There's like a wave button. I'm going to try pressing a wave, see what it does. Oh, there you go. I waved at Medina Sai. I've never done an Instagram live before, so please bear with me. It seems okay so far, but oh, Kazakhstan, amazing. Okay, there's a lot of like people from India. That's really cool. Based in US. Okay, I'll give it another minute and then I'm gonna start talking about myself a little bit and my research. Hopefully it will be interesting. Please do send me questions. As I said, I want this to be a two-way thing. Okay, so let's think. So, hello to everyone here. My name's Emily Richardson. I'm a second year PhD student. You probably would have heard this in the intro, but just in case you haven't. So I'm a second year PhD student. It was actually my 1 year anniversary 3 days ago, starting in the lab, so that was really cool. So I'm based in Leicester in the UK. I work in a lab under the supervision of Professor Andrew Fry, who's a really, really good supervisor. I've loved this year, had a really good time in my PhD. Obviously there's been lots of ups and downs, as there always is with these things. Hello everybody just joining. I've only just started, so don't worry, I haven't missed anything yet. So yeah, that's sort of like my base at the moment. So as far as my research goes, broadly, I'm looking at cancer metastasis. Hello. Bachelor's in biochemistry. Nice. Yay for biochemistry. I forgot to mention, so my undergraduate degree was in biochemistry. Hi, George! So biochemistry and molecular medicine. And it was actually George who's just popped up who came up with the name Biochemily. So that's really funny that he just popped up at that time. So yeah, that is sort of the advent of Biochemily. So my research, sorry, going back to that, I got distracted. My research is on metastasis, metastasis in lung cancer, specifically non-small cell lung cancer. And non-small cell lung cancer makes up about, I think it's 80-85% of lung cancers. The other part is small cell lung cancer, and that's mainly caused by smoking. So don't smoke, kids, it's bad for you. We all should know that by now. But yeah, so I'm looking at the non-smoking caused cancer. So it's sort of all mainly genetically derived or, hello Wade. It's, yeah, sort of genetic or just generally like cells going crazy. And causing lots of horrible things. So the reason we're looking at small cell lung cancer and lung cancer is because it's really, really metastatic, which means it has the capability to move around the body a lot. And actually, I think it's 90% of all cancer deaths are due to cancers moving and being able to move around the body, so metastasis. So it's really important for me to look at the mechanisms as to why cancer moves around the body, because potentially if we know how it can do this, potentially we might be able to find a way of stopping it, and maybe using that in combination with traditional chemotherapy. I'm just reading. I read that somewhat gene has potential in 60% of the population to be expressed for lung cancer for non-smokers as well. Yeah, so that's correct. So there are various mutations that can be common across anywhere. So anyone can have the mutations, whether you smoke or not smoke, and that is why there are two types. So there's the type that is just caused by smoking, which is the small cell lung cancer, and then the non-small cell lung cancer, which is, as you say, there is a gene that has potential to cause that sort of cancer. So that's sort of why I chose lung cancer. Well, why we're focusing as a group on lung cancer. Oh, hi Ellie! I just noticed that Ellie's joined. Hi. I'm gonna wave at you. Yay! Life is very bizarre. I'm still trying to work it out. Anyway, so please do send me questions. I'm enjoying people sending messages and saying hi and stuff, so please continue to do that. it makes this whole process slightly less weird and slightly less that I'm just like talking to myself. So yeah, hi Jim. Nice to say hi. And yeah, please, any questions that you think of just coming up while I'm chatting, please do let me know. Hello Harishma. Hi. So yeah, so metastasis. I don't know, is everyone from a biochemistry, cell biology background? Let me know. I've got a question here. Okay, so Blue Sunbird, you've just asked a really interesting question. So why are some tumours detected early in life, but metastasis takes place later in life? That's a really, really good question. So you can have a tumour, for example. So if you have a tumour and it's detected because you get symptoms, you go to the doctor, they scan you, they find blood tests, blah, blah, blah. They can do sort of like early treatment, and often that is like cutting out the tumour. Obviously that depends where it is and what the cancer is. This is very broadly speaking. But so if those cells haven't become metastatic yet, you may have heard that word used. So that's the key word. If they haven't become metastatic, then cutting out the tumour is a really good way of getting rid of it, because it's just sitting there. It's not really doing anything. It's just think of like a ball of cells. However, if it has become metastatic, potentially like even if one cell has left, that can be travelling around your body. So say, you have the treatment, they cut the cancer out. At that time, something could be going around your system and could have already landed in another site. It's a really complex process, and sometimes it's quite hard to find it until those travelling cancer cells have found a new place. So I have actually got a slide here ready just in case. So just explaining about metastasis. If I turn around. So here we go. So this is metastasis. So you have a primary tumour. The tumour can then gain mutations, which allows it to invade. It can then go into the bloodstream where it will travel around. There are lots of different factors, which means it might not get that far. It might be destroyed by the immune system. It can then go to another, say, organ, and then make its own little colony, and that's where you get secondary tumour. So that's why cancer is really annoying because it can be very sneaky. It can gain different mutations, which gives it a different sort of evolutionary advantage, so to speak. So yeah, it can be very tough. But as I said before, that's why I'm interested. Did that answer your question, Blue Sunbird? Bluebird. It's a pub down the road, I'm sorry. Medina colon cancer stem cells. Oh, very interesting. I love stem cells. It's super complicated, but yeah, stem cells are amazing. Really amazing, really important part of research. Yeah, I got the thumbs up, so I assume that means that answered your question, Blue Sunbird. Any more questions, let me know. So, I'm just going to have another sip of tea, because all this talking is quite tiring. Who else has got a drink or a snack with them? Let me know. I'm big on snacks and things. Anyway, sorry, I'm trying to avoid the sun. It's quite bright here in England, amazingly. The weather's actually quite nice today. So my research in particular, oh, thanks, that's really kind. Someone said I'm beautiful. So my research is looking at this thing called actin. Oh, can I briefly say what is metastasis? Okay, so I might have to repeat this a couple of times, but yeah, this is essentially the very important point. So metastasis is essentially cancer cells escaping their primary site and moving to a secondary site. So quite often doctors will refer to a cancer as metastatic, and that means that it has moved. and it is able to move around the body. It's gained mutations that means it can move around. I'm pretty. So yeah, that is that. If there's anything to remember from this conversation, it is that what metastasis is. So what I was going to say. So the thing that's most important, one of the things that is really important in metastasis, and what I'm looking at, so I obviously think it's the most important thing, is this thing called actin. So I don't know how many of you are sort of science-based, but I'll quickly just say what actin is. So actin is part of the cell cytoskeleton. There's a couple of other parts, so you've also got microtubules and intermediate filaments as well. But I'm most interested in actin. So you can kind of think of actin as it's called the cytoskeleton. So essentially, it's like your skeleton. It allows you to move. It sort of keeps the cell rigid, keeps it strong, and that's what's important. So in cancer cells, actin is super important. And the reason it is important is because cancer cells want to move. They want to move to get out of their primary tumour, to then get to a place that may have more nutrients, may have more blood vessels, all that sort of thing. So the actin cytoskeleton will jig about, essentially, and certain mutations in certain proteins, which I'll get onto later, and sort of upregulation of proteins and downregulation of other proteins, can mean that the cytoskeleton becomes more active. So in my research, the thing that I'm looking at is these things called Invader Poda. Now, Invader Poda are essentially little protrusions that come out of the cell. Actually, I've got a photo somewhere. I'll find it, yeah. I'll show you in a second. So they're little protrusions that come out, and they secrete these things called matrix metalloproteases. And these degrade the surroundings around the cancer cell, which means that the cancer cell can escape out of its little environment that it's in the first place. It can degrade through other cells, degrade through the sort of matrix that surrounds it, and it can get to the blood vessels. And once it's in the blood vessels, it can run away. So I'm really interested in Invader Poda. I'll show you a picture of what an Invader Poda actually looks like under the microscope. It's really, really cool. I found the other day. So it looks like this. So this is a cancer cell here, and you see that little green bit there? That is an Invader Poda, and that is an Invader Poda squeezing through the hole that the matrix metalloproteases have made, and it can then essentially get through. And this is an Invader Poda. This is a really amazing picture. So this yellow here is actin, the stuff that I'm interested in. This blue bit here is intermediate filaments, and that red bit there is a microtubule. So the other that are also cytoskeletal. Does anyone have any questions? Please keep talking to me. So it says, can we get all the recent useful live videos uploaded? I will forward that to the Addictive Brain when I speak to them later. Because yeah, these live videos are awesome and really useful, and it's really good to see all the different research going on and lots of stuff about PhDs and like what a PhD is like. If you guys want to know anything about how I found a PhD and all that, just let me know, and I will answer that question for you. So, any questions? Is there a probable treatment? Okay, so we've got a question. Is there a probable treatment or prevalence before expression of cancerous gene or mutations by now so far? So do you mean, I'm trying to work out what you mean by that. Do you mean like, is there a way of treating cancer before it happens? Is that your question? Sally 330. I'll answer it in a minute. I'm going to write that down with my other question. Treatment pre-expression of gene. Okay, I'll have a think about that and I'll answer that in a second. Yeah, okay, so I guess what you're sort of getting to is, could you sort of almost vaccinate against cancer? I kind of feel like no, because the problem with cancer is, and the reason why there is no cure for cancer, which is something that is really, really important, because there are so many people that think, like, you know, scientists are holding back the cure, or pharma or whatever. There isn't a cure. The problem is that every cancer is unique. You get different mutations, and they in a way they almost happen randomly, a lot of them, unless they're genetically sort of caused. Ooh, get out of the sun. Stupid sun in it. I can't believe it's sunny in England. And yeah, I mean, I guess unless you know you've got a genetic predisposition, so like sort of like BRAF mutations, or the breast cancer gene is quite a common one that often comes up. I don't know of any work being done on that. If anyone knows it, please join in the conversation. But yeah, I'm not sure if like pre-treating cancer can work, because also a lot of the cancer treatments are quite toxic to your body as well. So you may have had like chemotherapy, obviously you lose your hair, things like that. So sort of having that as a treating yourself with that when you actually have nothing wrong yet is never going to work. So I don't know. Maybe if once like gene therapies start to become a really trusted and well-known thing, BRCA1, that's it. Yeah, once gene therapies become more common, potentially that could be a thing. But for the moment, I don't know of any. But yeah, good question. Really like that question. I'm just going to shut these blinds. Oh God. So that's even worse. That's a little bit better. Okay. Apart from that, there we go. Right, so I got to talking about, I'm just going to move on. If anyone has any more questions, please continue them. So I got to the point of talking about, so I've talked about lung cancer and why I'm studying it. I've talked about invasion and metastasis, and then invasion, and why the actin cytoskeleton is really important. So I guess the logical next thing for me to talk about is my favourite protein, which is cortactin. So let me talk. Hi, Science Dose. So cortactin is my baby. It's my little protein that I'm really interested in. So cortactin is involved in the actin cytoskeleton. So it looks a wave. So the I keep getting distracted. This is a terrible thing with this live thing. So cortactin is involved in actin branching. So what you need to imagine is a road, and the cell is constantly building a road throughout its sort of body, essentially. And what cortactin does is it makes a fork. So it can make the actin go from sort of like this to like this. So it sort of spreads out, which basically is really important in its movement. So actin will push forward at the front of the cell and then contract at the back of the cell, which allows it to move. So cortactin is really important in that sense. It's also important, oh, hi Vicky! One of my old colleagues has just joined. Hello. So cortactin. So it's important in a lot of other things within the cell. So, hello. So what else is it involved in? So sort of trafficking. It's involved in trafficking things between the sort of place where all the proteins are made to the end of the cell. And then it's also important in secreting things from the cell. So what you might remember is when I was talking about Invader Poda is that certain factors are secreted from Invader Poda which break down the matrix surrounding the cell. So these are called matrix metalloproteases. And cortactin is very, very important in this. It was shown in various studies that if you knock down cortactin, the cell is no longer able to secrete these factors and get out of its microenvironment. So cortactin is a very important thing within the cell. I've just got a question that I'm going to answer. So Jim, I've already answered. Is there any option to stop functioning of protease and or before the cell release into the bloodstream? Yeah, so you think, I've just answered. Yeah, if you inhibit this is only in sort of in cell studies, so this isn't like a used as a therapy, but yeah, if you inhibit cortactin, it does stop release of these proteases, matrix metalloproteases. Whether that is a potential therapy or not, obviously, is going to take a lot more time because cortactin, as I said, is important in a normal cell. So it as I said, it does trafficking, it does release of things. It also helps cell adhesion, so how the cells sort of cling together. What else does it do? I've got another slide here somewhere. It's really important in cilia. And so cilia are the little like antennae of the cells, like this. So they essentially send and receive signals to other cells. So it's the cell's way of communicating. So they're quite important. And also just general cells are able to move around as well, using things called lamellipodia and also filopodia. So they're little cell extensions which help the cell to move around. So I've got another question. I'm sure you've distracted you again. I like being distracted. It's part of my nature. So some data suggested relation of glutamine deprivation and cancer cells. Are you aware of anything like that? I'm sure I've distracted you again, but if you have an idea, please share it towards the end. I have heard of glutamine deprivation. It's not really my thing, but I'm going to write that down because it is a really interesting topic that I know has come up quite a lot in cancer research. Obviously, there's so much cancer research going on right now, and so many people doing lots of different amazing things to try and tackle cancer and lots of different cancers. So but yeah, thank you for asking that question. I will certainly try and look at it later. Oh, that thought, so I'm getting really thirsty from all the talking. Any more questions, please just keep sending them, because yeah, this is really fun. I'm enjoying this. I was super nervous about doing this. I was worried no one was going to turn up and no one was going to sort of talk to me, and I was just going to sit here So yeah, this is good. So please continue talking to me. So I'm interested in cortactin. That's sort of where I got to, didn't I? So it's really important in Invader Poda. It's really important in secreting matrix metalloproteases. In this way, it's overexpressed in a lot of cancers, so a lot of different cancers. So it's overexpressed, which means there's a lot more of it in... I've written it down somewhere. So it's definitely head and neck cancer, which is pretty cool because this week is Head and Neck Cancer Awareness Week. So yeah, it's really important in head and neck cancer. It's overexpressed in breast cancer, in bladder cancer, in lung cancer, obviously, which is why I'm looking at it. Yeah, many different cancers. And actually, I got a really interesting question. So, a question I got, and I've written it down. I don't know, that's going to be backwards. That's not going to be helpful. So, I got a really interesting question from at Science, Health and Fitness, which is Natalie. So, thank you for sending your question. So I got a question saying, is there also a link to hematologic, I've said that so wrong, hematologic, so blood cancers, malignancies, or only to solid tumours? And I had to think about this one, because obviously I only deal in solid cancers at the moment, but blood cancers have always been quite a tricky one to treat. And the reason why I found it sort of interesting to look at and think about was because obviously blood cancers, they're just floating around. So you don't necessarily think that they need actin to move because they are just sort of like... whereas solid cancers are sort of stuck down, they've got to sort of creep along, move around, But, so I looked it up, and cortactin, the protein I'm interested in, is actually really important in B cell chronic lymph. Oh God, I can't remember. It's BCLL, which is, I've written it down here, chronic lymphocytic leukemia. So they found that when they looked at this cancer, cortactin's overexpressed as well, and that's because of what I said earlier, with it being important in secreting factors. It secretes this matrix metalloprotease 9, which is the bit that sort of degrades the surroundings. And so the reason that's important in blood cancers as well as any other is because of, again, invasion and metastasis. So although it is a blood cancer, it still needs to be able to get around. So that's why it's important. So in answer to your question, Natalie, yes, actin and cortactin are also important in blood cancers, despite them not having to necessarily move. They've still got to produce these Invader Poda and produce these matrix metalloproteases. So yeah, important in all the cancers. So that's why I think it's so worth looking at. So I've just got something from Genetics Research 101. So cetuximab is an inhibitor used for treatment of metastatic non-small cell lung cancer. That is correct. And that's interesting because I know that the specific sort of lung cancer that I look at, which is an EML4 ALK positive cancer, which I may or may not speak about later. It's quite in depth, so it's quite tricky to explain. But they quite often are not affected by cetuximab. Because they're so metastatic, they move around a lot, and that they kind of are able to avoid the effects. So yeah, that is interesting, and kind of again the reason I'm looking at all this stuff. So yeah, thank you for that. So Science Dose, hi, there is such a cool hypothesis saying that cancer cells could communicate with their surrounding microenvironment through gap junctions. Have you heard, is it relevant for your research? Specific, like for me, I'm not looking at that. Gap junctions are cool though. I mean, as I said before, cortactin is involved in junctions between cells. But yeah, that's not my research. But I was speaking to someone actually on Instagram the other day about this. I think it was Cancer Assassin, I think was their name, which is a really cool name. And he was talking about nanotubes, which are basically actin protrusions, and the cells use them to communicate to each other. And yeah, it's super interesting, all that stuff. Like you don't really think of cells talking to each other. But yeah, they use, you know, chemical messengers and that sort of thing, and yeah, it's really interesting and a really cool thing to look at. So yeah, gap junctions. Any more questions? Thanks for all the thumbs up. I'm enjoying all the thumbs up. It's keeping me going. I'm just going to have another cup of tea, just to refresh. Sorry, really not interesting watching me drink tea, but it's going to keep me going for the moment. Thanks. Thanks. So any more questions, please keep them coming. I'm just trying to think what else I can tell you guys. If you want to know about my PhD life, any more about my project. Oh, I know what I haven't talked about. Hi, March the Plankton, thanks for joining. So I haven't talked about the specifics of what I'm looking at. So obviously I said I'm looking at lung cancer, just to recap for anyone who's just joined or didn't hear me say. So I've talked about lung cancer, why I'm looking at lung cancer. I've talked about metastasis, what metastasis is. I've talked about invasion, what invasion is. And I've talked about cortactin, my protein. So obviously that's quite a broad subject. So what I'm very specifically looking at, which I'm going on to well cultured, is I'm looking at some very specific post-translational modifications of cortactin. So those of you without a science background, those of you, I'm going to answer some of your questions that you're asking because there's some really good ones. Lost my trail again. Post-translational modifications. So post-translational modifications are essentially things that can be added onto your protein after it's been expressed. I think that's probably the best way to explain it if you're not from a science background. So for example, you have phosphorylation, you have acetylation, you have ubiquitination. They're just three main ones. Obviously there are lots more, which I won't go into. But so the one that I'm looking at is phosphorylation. So phosphorylation, it basically, these enzymes called kinases can add these phospho groups onto your protein, and that changes the way it acts, usually due to a structural change. There's a lot to do with the charge of the protein and the way it will then it can be like this to start off with, and then you can get a phosphorylation, it goes like this. For example, that was a really bad example, but never mind. So I'm looking at the 4 or 5, currently 4, phosphorylation sites that we have found previous to my project. So this was all set up before my project. And they are based in the actin binding region of cortactin. And obviously this is really interesting because it's in the actin binding region, it may affect the actin binding ability of cortactin. So yeah, that's why we're sort of really excited about it. And then obviously we're looking at it in the context of cortactin's ability to do its function, which is to branch actin. And in cancer cells, that's then branch actin to then make invasion happen, essentially. So that's why we're excited about it. So a lot of the assays I do, so a lot of the experiments I do, are kinase assays, which often involves radioactive ATP, which is very new and also quite scary still, but it's okay. I do all the safety and everything. Also a lot of immunofluorescence microscopy, which I absolutely love. I'm a very visual person. So yeah, it's almost like making art out of science. It's really cool, and it also can tell you a lot. And then also a lot of Western blots. a lot of Western blots, and if you are a scientist or a researcher, you will know that that can get really tiring. But very important in a cell biologist's toolbox. So I'm going to answer some of your questions. I realised, like, as I was rambling along there, that some of you have asked questions, so I will just go back. So, addictive photographer, how long is a PhD in England? So it depends. I'm on a project where it's 3 years plus a year of write-up. So that's one option. The other option is you can get PhD, what do you call them? You can get PhD programs which are essentially a training program. So they're called DTPs, a doctoral training program. So they are where you can do a year of three-month placements in different labs. And often these programs are over a couple of universities. So you can try one in, say, you know, for me, if it was me, one in Leicester, one in Nottingham, one in Birmingham, for example. They're all sort of Midlands area. So you could do a 3-month placement in each and then choose which lab you wanted to go into. For me, I knew I wanted to go into the lab that I'm in, so that's why I applied sort of directly. But yeah, it's a good way of doing it because you get the whole 3 years in your lab to do the work, and then you get a whole year to write up, which I think is nice because you get the time to sort of think about it. You can work at the same time, I guess, if you wanted to. So yeah, I'm going to go on to the next question now. So, is your PhD exhausting? Can you see these bags under my eyes? Like, there is my teacher, she's doing her PhD as well as she teaches, and she's always down with energy. Wow, that's impressive that she's doing a PhD and teaching. I literally don't know how people do anything but just doing a PhD. I have a couple of colleagues who I know who are doing a PhD and they have kids, or they're doing it sort of part-time with work, and I couldn't think of anything else other than doing my PhD. I think having like a baby to look after would be a nightmare. Like, even just looking after myself is exhausting with a PhD. So yeah, it's very tiring. You have to put a lot of energy into it. You have to love what you do. And I've always said that is my big mantra. You have to love what you do, otherwise it is so much harder. And luckily I do love what I do. So it comes quite easy, you know, doing late nights or doing lots of reading as well as just being in the lab all day. It can be tiring, but I love it. So yeah, I think it's the same with sort of any science though, but a PhD is intense and yeah, it is tiring. Yes, science dose, yes. How did you feel on the first month of your PhD? Everyone is such an expert and I am not yet. That is my personal feeling. Oh, so have you just started your PhD? I assume that's what you're saying there. The first month is quite intimidating. Yeah, there's a lot to know, there's a lot to do. If you haven't been in that lab environment before, like as a master's or in a different job, it can be super hard. You've got to learn all the techniques, you've got to, know your project. You want to impress your supervisor. I found that the most difficult thing when I started. I really wanted to show my supervisor that I was worth him putting the effort into employing. So yeah, I did find it super hard. And don't worry about finding it hard. It's natural. And it shows that you care, essentially, like I just said. Like, if that's what you want to do, you just carry on doing it and you will get there. Don't worry about it. Okay. Next question. Addictive photographer. What do you enjoy the most in your PhD? Do you teach? Okay, so first question, what do I enjoy most? Cold tea, delicious. What do I enjoy most? I enjoy most when I get a nice result. Obviously, I think that is sort of obvious. Same in any job. If you get a good result, if you do a good report, it's always going to feel good. And proving your hypothesis right is always nice. But I also, as I said, I really enjoy doing fluorescence microscopy. That's always really fun, although the microscope room is always super cold because you've got to keep it cold for the machinery to work. And so that can be, it's like a love-hate thing. I love doing it, but then I'm always there in like 10 layers and it can get quite cold. And do I teach? This is quite interesting. I'm going to be doing a bit of teaching, but it's going to be more of a demonstrating role. I think in the UK they want you to concentrate on your PhD rather than doing a lot of other teaching. And obviously I am funded, so I get a salary anyway. But I'm going to be doing some demonstrating in the next couple of months, so to undergrads in labs when they're doing their practicals. So I'm really looking forward to that. I really enjoy sort of helping the younger generation to carry on enjoying science, and hopefully I can sort of share a bit of my enthusiasm. Science says, yeah, woo, PTMs, I know, we all love PTMs, and Sally can as well. Love PTMs and transcription. Lots of thumbs up. Sorry, I'm so behind on these messages. Western blots and me have a love-hate relationship. Yeah, me too. I think we all feel that. Western blot could be a pain in the ass for your best friend. I am dying to do a Western blot. Well, it is super fun. You'll have a great time, Sally Khan. I hope you get to do one soon. All depends on the antibody and interspecificities. March of the Plankton. Are you thinking of doing a postdoc or a fellowship? I don't know. I'm definitely going to continue in science. Whether I do a postdoc in academia or potentially whether I go back into industry, I haven't decided yet. So if you didn't know, before doing my PhD, I was working in industry, and it is really, really good fun working in industry. And yeah, it obviously depends on your company as it depends on your university and your supervisor, but I had a great time in industry, so I definitely haven't ruled out going back. I haven't ruled out continuing as a postdoc yet. I think it would be good to get that postdoc experience, maybe go around some new universities, go abroad potentially. But yeah, I haven't quite decided yet, and it's something I need to start thinking about for sure. So thank you for that question. Hi, how are you, Hamziki? I am good. I'm enjoying this. I can't believe it's been like 50 minutes of me just talking. So, wow. I'm probably going to have to wrap it up fairly soon. So any last questions, please let me know. I'm still scrolling through. Science Day, it's good to hear the feeling is normal, thanks. Yeah, absolutely normal to be nervous in your first couple of months as a PhD student. You will get into it, don't worry. Woo, good results, the best feeling. Hi, how are you? Looking good. Woo, thanks. Yeah, we're having a great time. Me and my lobster are just chilling. As I said this at the very beginning, but this lobster is from Boston. I went to a conference there about a couple of years ago. I can't actually remember when it was now. A couple of years ago. And went to Boston, so obviously I had to get a lobster because they're really good in Boston, and I had a lot of lobster over there. I had a really good lobster mac and cheese. So yeah, he just sits, I'm in my kitchen at the moment, so he sort of sits out there looking a bit sad. I'm not going to cook him, don't worry. Hello, Quantum Man. Hello, thanks for joining. So any last questions? I'm probably going to wrap it up fairly soon. I'll give it another 5 minutes if anyone has any last minute questions for me. But I'm getting quite exhausted of talking. I didn't realise how tiring this would be. I'm going to have some more cold tea. Please send any last minute questions you have. If not, send me some questions on my Biochemly account. And I can get back to you. I'm always open to talking about science because I love science. I'm looking tired. Charming. Charming. Not as tired as I did before I put makeup on. I looked real tired before then. Oh, thanks for doing this, you rock. Oh, that's so nice to hear. Honestly, it's really nice to hear that people actually even like listen to me or go on my page. I'm always amazed by the amount of interaction we get on Instagram. I just think Instagram is amazing. This community we have on Instagram for science has just been awesome. So thank you for getting involved. I think I will wrap it up now. Last minute questions, any? Let me know. Just message me. I think this will be up on the Addictive Brain page. I'm going to save this straight after, as Jemima keeps saying to me, you've got to save it. So I'm going to save it, and he'll put it up later, so you can always rewatch. And if you have any questions, let me know. What's your plan? What do you mean by what's your plan, Quantum Man? What's your plan, Quantum Man? I'm going to start getting myself into this. Yeah, what's everyone's plan for the rest of the afternoon before I sign off? Or actually, it depends what time you're on. I'm going to go and probably have a lie down after this, make another tea, have a couple of biscuits. I should probably go for a run, seeing as the weather's nice. Oh, about your Instagram and all that. What's my plan about my Instagram? I'm going to continue doing my Instagram. I also have a blog. I want to continue doing the blog. Short-term goals. Short-term goals for my... I don't really know. I'm honestly not a planner as far as social media is concerned. I kind of just do what comes into my head. So no short-term goals. I'm going to continue. I will think about that though, because maybe I should have a short-term goal. You've got me thinking. I will have a think about it and let you know in the future. But yeah, just keep a watch out, keep following me. Make sure you're like subscribed on my page. I know sometimes it won't come up in your feed if you're not. So yeah, hopefully I can continue to keep making science exciting for you guys. And obviously, please share all your stuff too. I'm going to sign off now. So thanks very much for watching, everyone that's watched on and off. And yeah, have a good rest of your Sunday. Have a good rest of your week, or beginning of your week. And see you later. Bye-bye, and bye from the lobster. Bye.